Hello and welcome to the Chapter 5 review, Part 2. Here we pick up some quadratic formula problems, and I've already written them out to save our time a little bit. So the first one is here, so we can identify the number in front of the x squared is 1, that's A. Then B is negative 5 and C is 6. We plug it into the quadratic formula, which is the opposite sign of B. So since B is negative 5, we put in positive 5. And B squared minus 4 times A times C all over 2A. Now it's important to work this part first. Negative 4 times 1 times 6 is negative 24. And we know that negative 5 squared is 25. So I'll do that, and I'll multiply the 2 times 1 to get 2. Then here I can subtract those to get 1. And I know the square root of 1 is positive and negative 1. So that gives me two possible answers, 5 plus 1 divided by 2. Make sure you don't just type this into your calculator, 5 plus 1 divided by 2. You're going to get it wrong. Do 5 plus 1, enter, and get 6, and then divide it by 2 gives you 3. 5 minus 1, enter, gives you 4. 4 divided by 2 is 2. Over here we got 3, 10, and negative 5. So we've got opposite sign of B, so that's negative 10, equals B squared minus 4 times A times C. When you multiply a negative times a positive, that's going to be negative 12. And then a negative 12 times a negative 5 is positive 60. So this is going to be positive. And when you add those together, we get positive 160. Taking the square root of that is 12.65. So again, I write my two equations. Negative 10 plus 12.65, add that up, that's going to be 2.65. Then divide by 6.44. Negative 10 minus 12.65, then divide by 6, negative 3.78. The next problem, we've got Ms. Wasak throwing a ball up in the air. So we can, again, use quadratic formula ABC. Opposite sign of B equals B squared minus 4 times A times C. Now again here, a negative times a negative is a positive, and a positive times a positive is another positive. I squared 35 on the calculator, added those together, took the square root of 1609, and that's 40.11. So that gives me my two possibilities here, negative 35 plus this, add it up, get this, divide by negative 32 gives me negative 0.16. Or the negative case, so I subtract, that's negative 75, dividing I get 2.35. Now the thing is, only one of these really makes sense. She's throwing it up here and it's landing. So what we're talking about, x is talking about the time, and y is the height. So when y is 0 is right where that x-intercept is going to happen. It's going to come up, it's going to land. We're looking for where is y 0. It doesn't make sense to have negative 0.16 seconds. So she probably threw it from a little bit high up, so it never actually got there. But it's landing at 2.35 seconds. The graph will look something like this. So she's throwing it maybe from here, and it's landing here. We don't really need to consider the negative because that's not really going to happen in practicality. But we can use it to find the middle of the parabola. We know if we average those two x-intercepts together, so if we add them together and divide by 2, that gives us the middle of the graph. So right here in the very middle is 1.095. We know that's where the vertex will be on this axis of symmetry. So then if we take that number and we plug it back in up here for x, and we put 1.095 here, 1.095 there, we can figure this out. So that's what I did. I did it on the calculator. I plugged that in, and I got 25.14. which tells me that when the time is 1 second in, it'll be 25 feet up in the air. I must have thrown it pretty high. So that is our maximum height, and it occurs at this time. Now we've got a sequence of problems dealing with absolute value or squaring. So remember, absolute value means the distance away from 0. So this thing is 29 steps away from 0. Which means either the 3x plus 5 is 29, because that's 29 steps away from 0, or 3x plus 5 is negative 29, because that's also 29 steps away from 0. On either side, it's equal to both of those things. So we need to write both equations to show that. Then I just solve for x. This one's 24, so x is equal to 8. Or this one is negative 34, so x is Negative 34 divided by 3 that's going to be 11 and 1/3. So let's say 11.33. Those are the two values both for x. Here, the whole side is being cubed, and that's the only thing there. So to get rid of cubing, we can cube root. We can do the opposite. Let's cube root both sides. And that cancels the cubing and just leaves the stuff underneath. Cube root of 27 is asking what times itself is 27. Well, that's 3, because 3 times 3 times 3. Not negative 3, because that would be negative 27. But the cube root of 27 is 3, so when I add 9 to that, I get 12. Down here, I would love to square this square root and undo the squaring, except for this 4. When you have a 4 in front, we have to get rid of that first. It's being multiplied, so let's divide it. So that gets rid of this and leaves square root of x plus 8 equals 5. Now I can square both sides because the whole left side is being square rooted. So when I square the whole side, it'll cancel. X plus 8 equals 25. So if I subtract 8, that gives me 17. Over here, I've got absolute values. So I got to peel away the other parts. I got to move the 6. I got to move the 2. Let's take care of the add-on first. Let's move 6. So 2 times the absolute value of x minus 3 is equal to 22. Now I'm not allowed to take this plain number and distribute it times the absolute value. Those are different things. Not allowed to do that. Please don't do that. I need to get rid of the 2 though, so I can do that by dividing by 2 on both sides. This gives me x minus 3 equals 11. Now I can set up 2 equations. X minus 3, since it's 11 steps away from 0, that would be positive 11 or negative 11. Move this down a little bit. It's in my way. X is equal to 14 or x is equal to negative 8. Over here. Okay, I would love to take the square root to get rid of the squaring, except for that 3 is in the way, and I can't distribute because this is being squared. So instead, I'll divide by 3 on both sides. That gives me x minus 5 squared equals 16. Now, all that's left is the squaring, so I can square root both sides, and x minus 5 equals the square root of 16, which we know are 2 different things. We know that 4 squared is 16, and also negative 4 squared is 16. So this gives me 9, and this gives me 1. Over here it's asking 27 to the what is equal to 3 to the 12th. Well, let's see if I can write 27 as 3 to the something. I know 27 is the same thing as 3 to the 3rd. So I could write it as 3 to the 3rd. That's a terrible 3, sorry about that. And I know that when I have power to a power, I could just multiply those exponents. So 3 to the 3x is equal to 3 to the 12. So if these bases are the same, that means that those exponents also have to be the same. So really, 3x has to equal 12. So x must be 4. So 27 to the 4th must be the same as 3 to the 12th, and you can check that on the calculator to make sure that that works. All right, here's your test review. Enjoy.